Hello everybody. This is a video about translations and reflections. I'm your host, Mr. Shirley, bringing the math like a boss. Now, I've included in Google Classroom a note that you can use, or a handout that you can use rather, to fill in some of the information in this lesson. I think it will make for an easier time for you. Okay, so to start off with, a translation is the movement of a shape without changing the size or orientation. Okay, orientation meaning what direction it's facing. Okay, so a translation just means you've moved it somewhere. All right, so in this particular chart here, we have moved the blue shape to where the red shape is, so it's just been moved there. Okay, you can see it's still facing the same direction. It's not gotten bigger or smaller. It's just moved. Now, a common way of describing some of these or noting these that maybe you'll see there is, so the original shape is the blue one, the new shape is the red one, and you can see the little apostrophe after each of the letters. Okay, so A has been moved to A. Apostrophe, it's often called A prime, which is the terminology I'll be using. So A has moved to A prime, C has moved to C prime, B has moved to B prime. Okay, it's just a way of noting the new coordinates and the new locations. All right, on we go. So on the chart on the side there, you can see that there's a translation. I believe I've included this in your note. So the blue triangle has moved to where the red triangle is, and there are a few ways that are typically used to describe that translation, to say to somebody what just happened. Okay, so one way is words. Okay, and you could say that it moved down 4 units and right 6 units. Okay, so if you look at point I here, if we go down 4 units and then right 6 units, you get to where I prime is. So that's the new location for I. All right, and the same thing would happen for T and R. Okay, to T and to go from T to T prime and R to R prime. Okay, the order for the words doesn't really matter. You could say right 6 units, then down 4 units. It doesn't matter. It's an English way of saying it. Now, there's a graphical way of noting this, which is sometimes called arrow notation. That's the green arrow that I've put over there. Okay, so again, my green arrow has gone, it doesn't really matter where you put it, but the point is that it's gone down 4 units, right 6 units, to basically map the direction that our shape has moved, to map the direction each point has moved. So if you do that, if you do what the arrow notes for each of points I, T, and R, you will get to all of your new points. All right, hopefully that's fairly straightforward. A third way of noting it is called coordinate notation. And that's where you're describing what's happening to each of the points that are around your shape. Okay, I deliberately picked a triangle so that there would only be 3 points that we would need to include in this, because you know, if you're doing an octagon, for example, and you have 8 points, it can take up a fair amount of space. So a triangle works perfectly for a video lesson like this. Now, point I is going from, so on the left side for points I, T, and R are their original locations. Okay, so point I is at -2, +8. Remember, it has to be horizontal coordinate, then vertical coordinate, so X, then Y. Point T is at -3, +3. Point 2 is at, or sorry, point R rather, is +2, +6. Okay, and then what you do is you draw a little arrow, and then you put the locations, meaning the X and Y coordinates, for I prime, T prime, and R prime. Okay, and assuming I've done all that correctly, that should be exactly where the new coordinates are. All right, so these are 3 different ways of describing what has happened during this translation of the blue shape there. Okay, and you would rarely do all of them at once unless you're doing a math worksheet. Now, the next thing we're going over is what's called a reflection, and you may have very well done these in the past, in past math classes, but it's very similar to notation, similar ways of noting some of the things that are happening. So a reflection is a flip of a shape over a line of reflection. So it's sort of like a mirror image. Okay, you can see that the shape has not, it's not moved like a translation. It has changed direction a little bit. Okay, so you can see that different points have moved different distances. Okay, but each point will be an equal distance from that line of reflection in the middle. Okay, so if this is the line of reflection right in the middle, point C is 2 to the left, point C prime is 2 to the right. Point B is 4 to the left, B prime is 4 to the right. Okay, so we're equal distance from the line of reflection. All right, now the line of reflection in theory can go in any direction at all. Okay, it could be straight up, it could be horizontal, it could be diagonal. In theory, it could be anywhere. I'll talk in a moment near the end of the note about some of the most typical ways of typical lines rather that are used for these kinds of questions. Okay, yes, on we go. Now, here's a quick example. So you could again describe a reflection using words or using coordinate notation. Arrow notation doesn't work nearly as well because every point will be a slightly different distance from the line of reflection. Okay, so depends what you're doing. So if you're looking at this picture, hopefully you can notice that the line of reflection in this case is the x-axis. Okay, so that's the horizontal line right in the middle there. Okay, so point R is 2 above, point R prime is 2 below, and so on. So describing the reflection using words, we could say triangle PQR, which is how you might name this triangle, is reflected in the x-axis. Okay, so it has just used that x-axis is the line of reflection. Okay, you can also do it using coordinate notation in a very, very similar pattern or method to when we did that using for translations. Okay, so you've got the original points over here, which are is the blue triangle, so 2 and 5 for point P. So 2 horizontal, 5 vertical, and then it's been mapped or moved to 2 and then -5. Okay, now hopefully you'll notice a few of the patterns in this particular line. In future years of math, you'll pay a little more attention to exactly where some of those end up, but we won't go too much into that one right now. Okay, now I want you to try this one out. So the blue object has been reflected in the blue line. So this is a diagonal line of reflection. Which is the correct image? So there's A, which is the green shape, B, which is the purple shape, C is the brown shape, and D is none of the above. So pause the video for a moment, see if you can figure out what it would be. Okay, I'll assume you did that. So when you're trying to find a reflection in a line that isn't horizontal or vertical, you have to be a little more careful, but you still want to pay attention to which points are equally distant. Okay, so in our case, for example, C cannot be it because it's basically on the line of reflection. That's very unhelpful. Okay, A cannot be it because the points are not equally distant from the line of reflection. Okay, so for example, this bottom right point in the blue shape, oh, you know what, bad example, that is actually equally distant across the line. The top shape here, which is at -1 and 2, right there, I've got the mouse cursor over it, hopefully you can see that, it's 3 from the line in the direction of the reflection here, but only 1 on the other side of it. So the distance is not the same, meaning it's not a reflection. Okay, and if we look at shape B here, you can hopefully notice that we're going similar distances each time and at right angles across or perpendicular to the line of reflection. Okay, so we've gone straight across that line of reflection. All right, so you can see that the bottom point here is only 1 unit, kind of at a diagonal there, distant, okay, from the corresponding point here. But note that B has been shifted a little bit because you're reflecting in a diagonal line. Okay, so things will change just slightly, but each point is equally distant. Okay, this bottom point right here, let me see if I can get the pen tool out to make this a little clearer. Come on, pen tool. There we go. So if I'm looking at this point right here, that would correspond with this point on the shape, sort of the bottom of the L shape here. And that is, so 1, 2, and a half kind of from the line of reflection, and on this side we have 1, 2, and a half. So we're equally distant straight across the line of reflection. Okay, so B is definitely the correct answer. Okay, and make sure even if you saw that right away that you have some idea of how you might explain that if somebody asked. So yes, B kind of just looks like a reflection, but you'd need to give some detail about why it is. Okay. Now the last page, the lines most commonly used as lines of reflection, okay, are one of the two diagonals, okay, and if you see a diagonal line, often it will go right through the origin point, which remember is 0, 0, and often the horizontal and vertical, sorry, I put my mouse over those backwards, but the horizontal and vertical axes are often used as lines of reflection as well. Like I noted earlier, in theory, any line could be a line of reflection, but usually they're either straight up and down, straight left and right, or perfectly diagonal, if I can use a not very mathematical phrase, because those are just much, much easier to get a reflection out of, okay, to figure out what the reflection should look like. Okay, so please try out the work that I've assigned to go with these two things, and please ask me questions in all the usual ways if you run into any difficulty. Thank you for listening. Have a super day.